this is John from caveofprogramming.com. In this tutorial we're going to look at pointer arithmetic in C++. So I'm still thinking about how I'm going to organise the videos in this course, but I'm probably going to put this video after one on pointers and arrays. And if you have seen that video already, then you will have seen some of the stuff that we're going to do here. But whether you have or not, this stuff is worth going through a couple of times, and I'm going to go through some stuff here that I haven't shown you in any other video in any case. And it's quite important stuff to know as well, because you do use it. I have used this in actual programs, believe it or not. So I've got here an array. Yes, I'm definitely going to have to put this after the video on pointers and arrays. Let's create a pointer to the start of this array. So I'm going to say string pointer p text equals text. So that, you'll hopefully remember, will now point at the first element in the array. And we could do cout, dereference the pointer. So thing pointed at by p text. And that's going to give us the first element in this 5-element array, which is going to be the string 1. Let's just run this and check. So it says 1. I'm going to put the number of elements in here because I think I want it later on. So we've got 5 elements, 1, 2, 3, 4, 5. So the number of items in the array we can specify there, although it's optional when you initialize an array like this. And actually, I'd like to be able to use that number later. So I'm going to say int elements equals 5. And I'm going to put this here, elements. Now, a common thing to do is, if you've got something like this, an int which or any value which you don't want to change in your program, you don't want it to ever change, because if we change this now, it wouldn't be the number of elements in the array anymore. Then you can put const in front of it, and that means that I now can't change elements. So if I set elements equal to 7 now, and I try to compile the program, it will give me a compiler error. It just wouldn't compile, which is what I want. That's like a safety check to make sure that this now can't change. It's also quite common, if you've got a constant, to put it all in capital letters. So let's say n strings, meaning number of strings. You could put an underscore there if you want, but this looks quite funky, so let's just use this and let's put that there. So we now know that that's fixed, and it's the number of elements in this array. So the program works. One thing we can do here is we can do addition with pointers. We've seen this in the video on pointers and arrays, but if we incremented p text like this, p text, if we add 1 to it, which we can do, the shortest way is to say ++. We could say equals p text plus 1. Let's do that first just to see it, and then let's do a cout on thing pointed to by ctext endler and run this. Then we get 2. So the shorthand way of doing that, again, we could do +=1. That would also work. Or we could just do ++. Or for that matter, we could do +=3. And then, so it started pointing here, and we add 1, 2, and 3. Now it's going to point at the string that says 4. So we can add numbers to pointers, and that will move it forward the number of blocks of memory corresponding to 1 unit, whatever 1 unit is. So in this case, it's a pointer to a string, so it's going to move forward by 1 string. If it was a pointer to a char, it would move forward by 3 chars in this case. In other words, 3 bytes forward, because a char is 1 byte. We can do subtraction as well quite happily. We can say p text negative equals 2. So if we move forward 3 to 4 and then we go 2 back, 1, 2, we expect it to now be pointing at 2. Let's try that. So I'm going to run that, and it says 2. We can compare pointers as well. So we can say, let's say string pointer p end equals, and let's set it equal to let's set it to point at the last element in text. So text end strings, and remember the last element in the array will be at the position, which is the number of elements in the string minus 1. So it's going to be at index 4, not 5. And that's because we start numbering at 0. So if we started numbering at 1, we'd have 1, 2, 3, 4, 5, and the 5th element would be at 5, which is the number of strings in the array. But because we start at 0, we've got 0, 1, 2, 3, 4. So we have to subtract 1 from the number of elements in the array to get at the last element, and it's very, very important to remember that, especially since the compiler probably won't warn you if you put a stupid number in here by mistake, and it's a common source of errors in C++. So now we've got a pointer to the end, we can compare these pointers. So as we saw in the video, I think we saw this in the video on arrays and pointers, but we can do stuff like this. While p text is not equal to p end, we can say cout thing pointed to by p text endler and p text plus plus. If we do that, we're going to get whoops, let's just see, we've got an error here somewhere. Oh yeah, I forgot to take the address of it. So yeah, that would actually give us the last element in the array, but we need the address of that element because this is a pointer. So let's just put the address symbol in there, and now we'll try that again, and hopefully that will work. So we get now 234. Well, this is a little bit confusing because ptext doesn't point to the beginning. Let's just do that. Ptext equals, and let's use this syntax again just to make it really clear and set that equal right to the start here. Now we're not going to output the last element here. We've got 1, 2, 3, 4, and the reason for that is when it actually gets to the last element, the loop stops here. If we wanted it to point to the last element, we could actually do this, and that would work. So let's run that. 1, 2, 3, 4, 5. So whatever you do, don't try to write the value here, and don't read it either, because it will be garbage. Reading it will give you garbage. Writing it will potentially screw up your operating system, and you'll have to restart your computer or something in the worst case. But as long as you remember that you mustn't read or write that, you mustn't read or write the value here. Nevertheless, you can point a pointer off the end of the array, which in this situation is quite useful. So you can point the pointer wherever you like, it's fine. It's not going to give you a warning or an error. Just remember that if it's pointing somewhere where you haven't allocated memory, then you mustn't start reading or writing that memory. But sometimes this is actually quite useful. We could also do pointer subtraction. We could so if I do let's say let's do this again, set it back to the beginning. Okay, I'll put a comment in here, set ptext back to start. So if we set it back to the start, then we could do p end negative p text. Now the result of this should be a pointer, but the pointer that would be the result of doing this wouldn't be any use to us. It would point at some memory location, like memory location 5, I suppose, because we're pointing this just off the end of the array, and this points to the beginning. So the difference between the two will be 1, 2, 3, 4, 5. And That's no use as a pointer. We'd have a pointer pointing to memory location 5. There's nothing interesting in there. But we could do int elements, let's say, equals, and let's output elements, cout elements. So if we subtract one pointer from another, we can store that in an integer. Whoops, I should have called that elements. Let's say elements. Except that it probably should really be long, but in this case, I know that this is going to be a small number, so I can successfully do this. It could, pointers, they're actually, if I remember rightly, they're actually like a long type more than int, so you could store really big numbers in them, I believe. And so maybe it makes a little bit more sense to do this. That makes it a little bit clearer what's happening. So we use a long because we're dealing with pointers, and also we'll put everything in brackets and cast to a long, just to make it clear what's happening, although it worked fine without that. And that's going to give us the number of elements, of course, in the array, because the difference between the memory location of the first element and the memory location of the element after the end of the array is going to be 5. So if we take this first pointer here and we add 5 to it, 1, 2, 3, 4, 5, we get a pointer that's just off the edge of the array. So in other words, if we subtract end from start, we're going to get the number of elements in the array. I think that's all I want to cover in this tutorial. Well, there's one more little thing which is going to come in useful a bit later on, which is that suppose we want a pointer to the middle of the array. We could do something like, let's set ptext back to the start, and then let's say ptext plus equals, we'll do ptext plus equals n strings divide by 2, and then let's do cout of ptexts. So cout ptext. Well, this is going to give us, let's take a look. It's going to give us a memory location because I forgot to dereference the pointer with a star. Let's do this again. So we're getting 3. So we've got the middle of the array. So what's happened is we've done n strings divide by 2. Because we're doing integer division, it discards the remainder. So the answer to that, 5 divided by 2, because they're both integers, we're just going to get 2. We're going to discard the remainder. It's not going to be 2.5, just 2. And then when we add 2 to ptext, so ptext is there, 1, 2, we get the middle element in the array. And this kind of thing, or either this or something very similar, is going to be very useful in an exercise which I'm going to give you in a future tutorial. So I will give you an exercise that will help you with this later on, but just for the moment, if you have the motivation and energy, it's definitely very worthwhile just to practice this a little bit. Declare a pointer to an array and practice going backwards and forwards in the array. So practice addition with pointers, practice subtraction, practice comparing pointers. Just make up some example for yourself and check that it works as you expect, and see what happens when you subtract pointers, get a result in an int. And if you do that, to make it really worthwhile, think about everything carefully, as I've done as I've gone through this tutorial, and make sure everything's exactly what you expect. Probably will catch you out the first time you do this. You'll probably get something unexpected, but if you think carefully about why you've got the result that you have, you should be able to figure it out. So it's a bit of a puzzle there, but just make up your own examples, just like I've done here, and go through each of those different possible cases, and also check that you can get a pointer to the middle of an array as well. That'll give you a really good workout with pointer arithmetic. So that's it for this tutorial, and until next time, happy coding.